Hello, my name is Brad Taylor with Fluid-Aire Dynamics, a family organization started by my father just over 35 years ago. Today I'd like to talk about leaks in the compressed air system and how they affect your system, especially the cost of the energy production. A little bit about me. I started with my father right out of high school and been with the organization for about 20 plus years now. Engineered and built compressors in the early years of my life. I also worked as a technician in the field for over 10 years, giving me a lot of experience and knowledge I carry with me today. Have very much a passion for analyzing data, helping customers understand where their energy is going and how we can help lower energy costs through various types of controls and compressors. I've engineered and installed many pipework systems throughout my years. That gave me an understanding as to the dynamics of compressed air and how that affects the compressed air system overall. Today I manage a small team of sales engineers. It gives me a passion for learning and training them. This slide here is the overview of a typical compressed air system. Each of our compressor rooms include some type of compressor, maybe multiple versions of, and some type of filtration package, including a refrigerator dryer, maybe a desiccant dryer with pre and post filtration. We may have a wet receiver before that filtration, but typically we don't see that in smaller compressed air systems. And then as we leave the compressed air filtration zone, we go into our dry tank and then feed out to the header network system. We're going to spend a bit of time today speaking about what we refer to in the industry as the dirty 30. This is the last 30 feet of your compressed air system, where a majority of your compressed air leakage comes from. So when we think about the overall cost of a compressed air system, there's the compressor room that includes the capital cost of the equipment. And then there's the maintenance of the equipment. And of course repairs, and then there's the energy. We often think of the capital of the equipment as the most expensive, and the energy of course is free. Then there's the plant side or the demand side of the compressed air system, that when the system fails or there's a low pressure event, we have lost production, people standing around costing the company money, and of course higher scrap rates, unformed metal products, product rejects, whatever it may be. This here shows the 10-year cost of a compressed air system. It's the complete opposite of what we just spoke about in the previous slide. As you can see, the energy cost is the most expensive by far. In this case, about 73%. The capital cost, including installation, is only about 20%, and the maintenance cost is 7%. But yet we focus so much on the capital cost and the maintenance cost that we forget about the energy of our system. Typical leak rates of compressed air systems are astonishing. 10% of a leakage of a typical compressed air system is considered managed. 20 to 30% is typically what we see. In fact, the DOE, or the Department of Energy, claims that 25% is average. North of 50% is not uncommon and is unacceptable. Now just consider for a moment that 10% leakage equates to about $18,600 in this scenario. Your 10-year maintenance costs in this scenario is $18,000. So even in a tight system, your maintenance is less than the leakage. So I feel that we need to focus just as much, or maybe even more so, on the network, the maintenance of our network system, as we do in the compressor room. So here's a little critical thinking exercise. Do you leave your front door open? No, our parents taught us. In fact, they screamed it into us. Shut the front door, you kid. Do we let our faucet drip? No, it's annoying, and we know it's a waste of energy. Do we leave the lights on in the evening? No, it's a waste. Why do we waste compressed air? Well, maybe it's not as obvious. Maybe we don't see it or can't hear it, or maybe we're up in the front office and don't spend time to walk out back and see where energy may be wasted. Maybe we waste compressed air because we don't understand its true cost. So what I'd like to do is help you guys understand the true cost, identify leak points and ways to tabulate, leak finding tools and methods, and then how to sell leak repair to management, and then maintain the gain. So let's get in the know. Let's understand what the cost of 1 CFM is. The formula is simple. In fact, many manufacturers publish their data through a KGI form or various ways in their product literature that explains the efficiency of the compressor, usually expressed in kilowatts per 100 CFM. If we take that efficiency number, which typically in a smaller system would range between 21 and 24 kilowatts per 100 CFM, and multiply it by the operating hours, multiply it by the cost of your energy, including taxes, we come out with something that looks like this: 22 kilowatts divided by 100 CFM, multiply it by 2,000 hours, multiply it by 8 cents. 1 CFM in this scenario for a single shift operation costs $35.20. Now we all have different operating hours, we all have different costs of energy, so you need to use the formula and calculate for yourself. Imagine a 2-shift operation, multiply this times 2. If you're a 3-shift operation, obviously, multiply it times 3. If you're a 24/7 operation, well, multiply it by 4.2. So now you can see what the real cost of 1 CFM. I'd like now to demonstrate what 1 CFM sounds like. I have with me here today a can of CO2 duster, Office Depot. They all work the same. They all have a small tube which acts like our regulator. This can, with the trigger pulled halfway back, equates to 1 CFM. What I'm now going to do is take that same 1 CFM and send it through a piece of tissue. What this is going to demonstrate is compressed air going through a muffler in maybe a MAC valve or a spool valve or some cylinder that's constantly leaking. The point here is you may not always be able to just use your hearing. You may need to use some form of data logging or metering. So now let's discuss various points of leakage within your compressed air system. I broke it down into 3 zones: the compressor room, the piping network, and the dirty 30. In the compressor room, I've commonly seen blowdown valves on the sump that are internally leaking, blowing the very expensive compressed air right back into the inlet filter housing to be recompressed. Drain valves stuck open, very common, and inlet valves. The cup seal or the O-ring seal internal of the valve is leaking the signal pressure, again blowing it right back into the compression chamber to be recompressed. Then we have the piping network. I don't commonly see a lot of leakage in this zone unless there's heavy vibration, such as a stamping outfit. If your system is welded, they're typically leak-free forever, unless they are leaking through with pinhole leaks in the center of the pipe. Then there's the dirty 30. This is really where the majority of your leakage comes from. The first point here is dust collector pulse valves. We have heard of instances where dust collectors account for 40% of a compressor room capacity. So you can imagine what happens when 1 or 2 of those pulse valves get stuck open. It can bring a complete system down. Then we have cylinder blowdown valves. These are the fast blowdown valves that allow the compressed air to vent, to allow a cylinder to retract quickly without having to go through long lengths of tubing. We have seen the diaphragms inside these crack and constantly blow air, and you also lose pressure or force on that valve, costing you in product rejects. Then we have hoses and couplers. Hoses are very porous. In fact, you may not even be able to hear the leakage in a hose with an ultrasonic meter. If they look cracked, replace them. Couplers, probably the most abused device in the compressed air system. In fact, I wish I could declare war on them or create some compressed air codes that disallow them. We don't put plugs on our manufacturing equipment, but yet we see couplers, multiple couplers in series feeding a compressed air machine that's costing not only pressure drop to the machine, but is costing leakage, especially on hand tools that are being worked back and forth, wearing out the O-ring seal internally. Then there's the production machines themselves. internal cup seals within the cylinders, packings. Some of the areas downtown Chicago here still use leather packings and seals on the cylinders. Spool valves. Spool valves, solenoid controlled, shuttle or operate thousands, in some cases tens of thousands a time a day. Those rubber seals crack or fracture, causing leakage internal of the valve. Then of course there's many O-rings that help seal faces of air motors, gearboxes, whatever it may be. Then motor vanes internal of air tools. As they wear, air seeps by those vanes, causing internal leakage. Then there's open blowing. Many in the industry may say that's artificial demand, but when that person walks away or that machine's not in production and the air is still blowing through that nozzle, I would call it an air leak. This view here is a picture of a typical production machine. Many stations and operations going on here. The point is that production managers want to see this machine running constantly. So there's challenges in conducting a leak repair. The maintenance department wants it down for 4 hours. The money counters, they want it 100% operational. So it becomes a challenge. And in this scenario here, there's hundreds of different fittings, many different tubes. So we need the time to be able to do a proper leak repair. And then there's some leaks that may not be worth it. Maybe this machine is producing some product that's worth $10,000 an hour. The leak rate on this is $50 an hour. In that scenario, it may not make sense to fix those type of leaks. But if you could tabulate this into a worksheet as to what the leak rate is, you know what your leak rate cost is, and you know what the production of the machine is, should make a very simple determination as to whether those leaks should be repaired or not. And I'm a Lego fan. I had Technic sets that my father bought me when I was very young. I do not pretend to say that leak repair is as fun as diagnosing something like this. It's not. It's hard work, but it has to be managed. Otherwise, we're just going to buy more and more and more compressors. And while that's great for the sales department, it's not really good for the sustainability of your business. Now, you heard me speak earlier about war on the couplers. These are real world instances that I see on a weekly basis, where we'll have a machine being fed by a hose that is split off to 2 other couplers. In this case, it's feeding another mini manifold before it finally gets to the machine. This particular instance, the customer was having low pressure machine errors. Every one of those couplers has a 3/16 orifice. We feed our compressed air equipment with nice, large 3/4 inch pipe, in some cases 1 inch pipe, only to have it reduced 3 or 4 times by a 3/16 orifice. And we wonder why we're shutting down our machines. So what do? We go to the compressor room and we crank up the pressure. That only costs more energy and feeds leaks at a higher rate. Here is another scenario where we came from the ceiling with a 3/8 hose, sent it through a filter regulator, and then to the machine. We have 4 couplers in this series here. This one is my favorite. We come down with a 3/4 inch pipe to a coupler, go to a coupler splitter. I think at this instance here, they actually extended the hose with another hose, had a coupler set in the middle, and then fed through the CNC machine. 4 or 5 couplers in that scenario there. Here are a few other methods or tools used to sum up the leaks in your compressed air system. You can use the leak down test. This is my least favorite because you really need to know the full volume of your compressed air system, including the head or pipe network. This is very tough to come up with that value. But if it's a very small system, it can be a very, very simple test. Then there's the flow meter, your point of use flow meters. This is great to find the flow of a particular production machine. The challenge with this type of method is that you have to put the flow meter into the piping network. Getting that downtime can be a challenge. Then there's ultrasonic. The more expensive meters, starting about $4,000 and up, can convert the dBA rating to a CFM value. I don't claim it to be very accurate, but it can be a way of putting a value on each of your compressed air leaks. The simplest is to do the pump up timing. If you know the value of your compressor's output, you can simply take the pump up time in seconds and divide that into the total cycle time, and then multiply that decimal value by the output CFM of the compressor. So for example, if my compressor loads for 10 seconds and is unloaded for 10 seconds, my total cycle time is 20 seconds. 10 divided into 20 is 50%, or the decimal value of 0.5. Say I have a 200 horsepower compressor that's putting out 800 CFM. I'd take that 0.5 and multiply it into the 800, and my value is 400 CFM. It's a very, very simple test to do. And then as mentioned earlier, there's centralized mass flow. There are some very nice meters out there that are inexpensive that you can install in the main header pipe leaving the compressor room. What I like to do is try and get some downtime. Typically a small plant can be done in a half a day with a couple of guys on cell phones. Set up the meter in the compressor room, valve off all the production equipment, and that will give you the value of your compressed air header leak rate. Then turn on one valve at a time, allowing the system to balance. Record that value and deduct it from the previous value, and that gives you the leak rate of each of those zones that you valve on. Very, very simple, and then allows you to focus on the zones that have the highest leak rate. And then you can get into the detailed areas using ultrasonic meters or zone metering to detail where the leakage is. Some tips on using mass flow meters is that they need to be installed on the dry side of the compressor room. They are a heat sensitive device, and if they get any water on the sensors, it will give inaccurate readings. The other point too is mass flow meters need to see a steady flow, meaning the compressor should be put into a modulation mode, or a variable speed drive should be the only compressor activated. When a load-unload machine puts air into the system, it is also filling other reservoirs that may be out there. When it unloads, that leak is now drawing from the reservoirs that are in the facility. So you will get distorted highs and lows as that compressor loads and unloads. So to get the most accurate constant readings, use modulation or VFD if they're integrated in the system. Inability to shut down the plant to install mass flow meters can be a challenge. There are some meters out there that claim that you can hot tap. I personally haven't used them, but I know they're out there, and if that'll work on your system, that's a great tool to use. And then as we had alluded to earlier, tally everything up on a spreadsheet with some type of a calculation that'll total up what the cost of each of your leaks are in that zone. I can provide you that spreadsheet if you'd like. So getting the team involved. I think this is probably the most critical part or component of a leak repair program. We know as we have problems, the best way is communication to resolve them. So I think there's 5 main areas that need to be communicated to the team. Firstly, we need to be educated as to the cost of compressed air. Then maybe get people more involved or excited about the leak repair program through some type of internal incentives. Maybe a certain number of CFM saves would earn a pizza day for the production team. How about mandatory KPIs? Some things are just part of our roles. If you hear a leak as a machine operator, you have ownership for that machine. You need to report it or tag it and let maintenance know. Awareness. How has the leak program been benefiting the company? How has the X number of leaks that have been repaired saved the company X number of dollars? People need to know that they're making a difference to the program that they're part of. And then involve your service provider. This is important also. They will often be aware of the incentives available from the energy companies, and they will be happy to tell you more about them. Maintaining the gain. You can't manage what you don't measure. We hear that often. We added the word continuously. You can't continuously manage what you don't continuously measure, because compressed air leakage reoccurs every day. Compressed air is very dynamic in its consumption. So it needs to be measured constantly so we can constantly manage it. The simplest form for managing your compressed air consumption is recording daily values at a certain time of the day, break time, lunchtime, shift changes, as to what the rate of consumption is from the mass flow meter in the compressor room, and record that on a spreadsheet, a Google sheet, a smart sheet, something that's collaborative is the best form so that everybody's in the know real time. Or if you have a building management system, Most meters can provide a Modbus or a process output to your centralized database. This way the front office can see it in real time as well, and it's all merged together with production data and whatever else you may have. There is finally some new innovation in the compressed air industry. I don't mean to belittle what all the great manufacturers out there have come up with, but really we've been working with piston compressors, rotor screws, and centrifugals our whole career. There's now IoT, the Internet of Things, that are making their introduction into the compressed air world. And it's allowing smaller manufacturers with smaller compressor systems to manage their compressed air system from their PCs and phones. Bigger, larger systems that have onboard centralized sequencing systems, this should be typical output data for your system. But for the guy with a 100 horsepower and down compressor, this is not a very common tool to have on board. This will give you true insight in real time as to the energy output of your compressor system, its efficiency, leak rate, and maybe even some features that'll tell you when the compressor is going to shut down. So now that you've fixed up your whole system of leakage, you'll need to get another snapshot of how your system is operating, and you may need to adjust your controls. The last thing you want to have is a more efficient compressed air system on the demand side, but then on the supply side have a compressor sitting in there running unloaded. So don't forget to do that. Talk to your energy provider about current incentives. Take advantage of them. Many of these incentives are utilizing your money that you've paid into the program. And finally, align yourself with a service provider that cares as much about your piping network as your compressor room. At the end of the day, compressed air energy costs much more than the maintenance it takes to run it. Thank you for your time today, and please reach out if you have any questions.